And now for something completely different.
There's a completely different view available to us on the calculator, and it's called the table view, and it can be quite useful. Let's look at the keys we would use to manipulate table view. The first thing you're going to have to be able to find to do this is the second key. Okay, it's like a shift on a typewriter, or I should say on a keyboard. It changes other keys, but it's towards the top left, and I'll show you it in a second. If we hit the second key and then hit the graph key, it changes the view from graph to, very logical, a second view, which is table. Now, if we hit the second key and then hit the window, remember the window allowed us to change the settings of a view. Well, second window allows us to change the settings of a table. And I need to show you where that is and why you would do that. So let's take a look. Here's the second key. And how would I hit second and remember where the graph key is? Don't hit them at the same time. Hit the second, let up, and then hit graph. And as you can see, it's a little cheat sheet up here. It tells you that that is table. It is the same color as the second key to tell you that. If you hit the second key and then let up and hit window, you'll get, now they shortened it here, it says table set, but it's the table settings. It's the setting for your table to change the way the table looks. Okay, so these are the keys we'll use. Second graph, which is really the same as table, and second window, which is equivalent to table set. Now, we recall that we could use these basic keys to actually get a picture on the graphing calculator. And let's do just that. I'm going to turn this baby on and use the y equals button, as we've done before, to enter this function, y equals minus 3x minus 5, into the calculator so that I can get a picture, and later a table. So I hit y equals. Remember that the negative button is down here. It's different from the subtraction button. Negative 3. Here's the x button. And now I'm going to subtract 5. So I use the subtraction button and 5. Now if I hit the graph button, which is right here, I'm not surprised that this is a line because it is a linear function, x to the 1th if you would. I also know that this picture contains an infinite number of points. That's why it looks like it's a line, but it's really a bunch of points real close to each other. For instance, this point right here, the y-intercept, is the pair 0, negative 5, isn't it? Got the idea? And these are all an infinite number of pairs. Well, we could look at those pairs in a table. And the way we would do it is to go to the table by hitting table view. And that would be second and graph. And as you can see, there's the point I just told you, 0, negative 5. But I can use the cursor keys to look at all of the points. Well, actually, it's not all the points, is it? There's a bunch of points in between these. These are only going up one at a time. But at least you can see the difference, hopefully, between table view and graph view.
Thank you, sir. May I have another?
Okay, let's do another graph and table of a different function. This one, is a constant function, y equals 4. I'll hit my y equals button up, and I remembered it remembered the last one I did. So how do I get rid of it? Remember your old buddy clear, which is right here. And I'll just put 4. And let's look at that graph as if we don't know what it is. It's a constant function right at 4, isn't it? What if I wanted to look at the table of that? Can you predict what that would look like? Every time y is 4, because this is a collection, remember, of an infinite number of points where y is 4. Well, let's look at the table by going second graph. And as you can see, using the cursor keys, I can go up and down. Nothing fantastic, is it? Y just is always 4. The x changes, but y is always 4. Now how do I go back to the graph? Just hit regular graph. So there are two views, table view, second graph, and graph view. I hope you appreciate it's probably logical that they're on the same button because they're kind of the same concept, just different views. Now you might be asking, what would I ever use table view for? Well, it's quite useful. Consider the following problem.
How about a little fire, Scarecrow?
The green function here closely models the price of a gallon of gas for time t in years since 1980. Now this is going to be a messy function, as you can see, because it's got decimals all over the place. The question is,
There's something I have to ask you.
when will the price hit exactly $5.25? Well, we're going to have to solve this equation. We're going to put in $5.25 for the price,
Alrighty then.
and we'll have to solve that equation. And we could use, I guess, if we subtracted $5.25 from each side, we could use the quadratic formula, but it would be quite messy. Actually, I can use the table feature of a calculator to solve this horrendously messy function. Let me show you how. I'm not going to get a 0 on one side this time. I'm going to just place the function as it stands into the y equals button. Now, remember that I can replace t with x. It really doesn't matter what letter it is, and I don't have a t button, so I'm going to have to do it with x. So let's put this function in as nightmare as it appears. Let's see, that's going to be 0.0089 t squared, or x squared. I'll go x to the tooth. Okay, minus 0.21, and I'll use the x again instead of the t, plus 2.59. Now I'm really not that interested in seeing the graph of this, but let's, just by habit, let's look at the graph. Okay, well, I suspect it's a parabola, isn't it? It's not a straight line, and since I see t squared, it is a parabola. Looks like it's going down from left to right. But anyway, let's look at the table, and I can see the various values, and as I use my cursor, the y value is going down. My cursor over there, see, it's going down. But maybe it'll come back up, because I want to see when it's going to be, in the question, 5.25. Let's see if it comes back up. See how I'm using the table and the cursor? It is coming back up. So I'm going to cursor to 5.25 and see what the x value is at 5.25. I went too far, and apparently it happens somewhere between here and here. So approximately x is 32 when y is 5.25. So I can answer the question, because it says years since 1980, by adding 32 to 1980, and I've answered the question. In what year will it hit exactly 5.25? Well, 1980 plus 32 is 2012. You got it. So I've answered the question using the table feature of the graphing calculator and working backwards, if you would. Now let's use the graphing calculator's table feature to solve another messy, if you would, equation. How about this bad boy?
Holy cow!
Now I know what you're saying. I wouldn't have any problem solving that using the least common denominator and multiplying through, I guess, of x plus 65 and x plus 70. But it would take a while, and it would be quite messy. And consider, I don't want you to just solve this equation for x. I want the answer to the nearest hundredth. I want a pretty exact answer. Okay? That's a job for a calculator. And I want it quick. Now, let me show you how I would do this one. First, I'm going to actually insert the right side of the equation in as a function, and basically I'm going to see when that function equals 9. Let's put it in. Y equals, now we have to be careful here because we have fractions. Watch what I do here, please. I'm going to put 261 And I'll use the divided by to create the fraction. Now if I put x right now, it's only going to have x as the denominator, and I need x plus 65 as the full denominator. So I have to incorporate some parentheses here. So I'll go parentheses x plus 65 and end parentheses. That ends the fraction. It's critical that I use those parentheses, otherwise I'd only be dividing by x and then adding 65 to the result. I hope you appreciate. Now let's put in the other fraction. Plus 522 over, or divided by, and once again I'm going to play the parentheses game. Parentheses x plus 70, end parentheses. Now I could look at this graph, but I really don't even care. I'm going to go right to table view. You don't have to go to graph, you can go second graph and go right to table view, and that's what I'll do. Second graph or table. Now I need to know, I'm going to cursor over to the y's here, when y is 9. It appears that the numbers are getting smaller as I go down. So let me look for 9. I'm getting close. Okay, now I went too far. Now I don't see 9, but I do know that the answer to this is somewhere between 18 and 19, isn't it? So, because, as you can see, 18 and 19, 9 is somewhere between these two values. Now, if I was just estimating, I'd be okay, but they've asked me to give the answer to the nearest hundredth. So I'm going to have to change the table using, as I showed you before, table set. And I'm going to tell it, I don't want to make the table too long, to give me the numbers between 18 and 19 to the nearest hundredth. Let me show you how we do that. Here's the table set. I had to go second window, and I'm going to tell it to start at 18, and I'll hit enter, and it'll jump to the next thing. Right now, as you remember, it's going up 1 unit at a time. I'm going to tell it to go up 0.01, or 100th unit at a time, and I'll hit enter. Now let me go back to the table, second table, and there I am at 18. Now I got to look for 9 again over here. The values are getting smaller, so let me cursor, and as you can see how the x values are going up 100th at a time? But I'm still going to get back over here and look for 9. It may take me a while, but at least I don't have to solve this equation on paper, right? Okay, we're getting closer to 9. Getting closer. Looking for 9.000. I'm greedy here. I want it really exact. Okay, well there it is. 9.00. So my answer to the nearest hundredth, how cool is that, is 18.73. You can see why we needed the table set there. We use the table normally, and then to get an exact answer, we start at the value that we need to do, and then go up whatever accuracy they asked me to do. See if that's not of use to you when you're ready to throw your hands up because an equation is so difficult. Be looking for using the table feature.
What's all this jabber-wopping when there's work to be done?
Okay, go give it a try.